Hi, welcome to the third video in our leaf tissue data series. Today we are going to be looking at potassium, and just like we did in previous nitrogen and phosphate videos, we're going to be looking at leaf tissue versus whole plant data, and we will be getting into some of what you can do with the data, especially to get into the year-end report. So you just saw the phosphate one we did in the last video. Here is the potassium slide. So this is a comparison of 100 plots where we did concurrent leaf tissue uh, for the K concentration in the leaf. We compared that to crop content. And you see the lab sufficiency range when you go up the y-axis is 1.75 to 3% for the timing of when these leaves were pulled. And we had most of our dots are going to be within that range. Now, compared to nitrogen and phosphorus, we do have a better R squared value of potassium. It's a 0.182, so that's a medium correlation in this case. It was very weak and nearly non-existent for nitrogen phosphate, so at least we're a little better for potassium. But we still have the same problems that it's not necessarily as you raise your leaf tissue. For instance, let's say you're on this grid line here of 150 pounds per acre of K2O. You could have a 1.75. This one looks like it's more in the middle, like a 1.9. You could have a 2.4, and here's some about 3. In fact, the 3 represented by this dot here that the laser's on is less K per acre than this one down here that is actually showing low according to the lab. Because remember, as you move to the right, you move to the right on the x-axis, that is an increase in the amount of potassium in pounds per acre that is represented. The dot moving as you move up, the dots are just showing a higher leaf concentration. Now you do see these guys down here in this cluster, they do have a lower concentration and they are leaning more to the left of the x-axis. So there's more of a correlation to what we saw in the previous two videos for nitrogen and phosphate, and that's why you have a higher R squared. But just because you're at 2.25 leaf concentration, which would be this line that I'm drawing out with the laser, you don't know if you have 150 pounds, 200 pounds, 250 pounds, or 300 pounds. And that is what tells you where you are yield-wise in the way of what your potential is. So the amount of potassium you have at a certain stage of uptake can set the trajectory of where that yield could end up. And when you're down here at these super low concentrations between 1 and 1.5, you are looking at 120 to 170 bushel corn. As you get higher, though, when you get that up to 1.75 to 2, you don't know whether you're still at 170 bushel corn or whether you're at, in this case, between 230 and 290. So it's like a 250, 260 bushel corn crop, still at 2%. All right, so that's where it's you can't rely on leaf tissue being higher to give you that higher yield promise. Okay, we'll show you what we do with this data at the end of the season, or what you can do with the data at the end of the season. These are side-by-side fields, same ones we looked at in the phosphate example in the last video. So over here, you will see your soil KPPM, and I've converted that into oxide pounds per acre. So field 1, obviously it's a heavier field, 16 CEC versus 6 down here. There was no K2O applied to this crop, but there were 103 pounds applied via some potassium chloride and some in-season potassium. Look at the crop uptake differences in these two fields. This one was 298 pounds in the biomass per acre. This one was 442. Now look at the final yields though. The K2O that was about 300 pounds was 265 bushels an acre. This one yielded only 7 bushel less, but it had 150-ish more pounds of K2O uptake. Guys, this is the luxury consumption that you'll see me post about and that I talk about. This one, when I put it up against the Agrimodis goal, the Agrimodis goal was 299 for a 260 corn crop. So I was right on it. I was within an eighth of a pound with the gall and what the actual crop uptake was. This one, my goodness, we have 150 plus pounds of excess potassium being taken up into that crop. That was not necessary. So if you're looking at that situation and you applied 103 pounds, would you keep doing that? That's where, even though the soil obviously showed that it was lower, did we quantify in that soil test all the potassium that those roots found? And in this case, I don't think it did. Let me give you another piece of info. Field 1 in 2022 had 180 ppm and it's gone up to 293. Field 2 had a ppm of 117, it's gone up to 142. The removal for a 260 bushel corn crop, which is pretty much where this is about 65 pounds. So of that 442, you're only taking 60 to 70 pounds of it away. The rest of it is spitting out the back of the combine. Unless you bale it or something, that's going to go back into that soil profile, not necessarily in the exchangeable pool of K that you would measure with Malic 3 or potassium acetate or H3A or pick your poison. You would catch it on a total digest. So these values were also taken with standing crop. Something you'll find specifically with K, if you do your plant uptake testing through the season and you take soil tests along with it, you will not see the soil K draw down as K accumulates in the crop. The way K dynamics work in the soil this isn't a bank account. You don't start out with 706, you take 300 up into the crop, and now you have 406. All right, you're probably going to hover around that 706 year long while the crop accumulates K. So just if you have it in your mind that this is a bank account and you're drawing away from it, this is great evidence that is not what's happening. Now, this is not the same field, but it's about the same situation. So I wanted to include this one also in the video just for a little additional K insight. So in this particular case, the soil had 212.5 pounds of K2O, and this grower applied 60 pounds. Now the goal for the crop at 240 bushel an acre is 275.1 pounds total, but the crop pulled up 300 pounds, meaning we were about 25 pounds over. Right, so what this grower is going to do is reduce that applied amount down to where they just have a little bit. We might only have 40 or 50 pounds of potassium chloride in the strip next year. Now, here's where you take that 300 pounds in the plant, and Agrimodis testing will split this out into how much is in your stover and how much is in your grain. That way, instead of using say a fertilizer removal app or using some chart your university is given, you have the actual test and that number in your hand. So it was estimated for 260 bushel, according to a fertilizer removal app, 65 pounds would leave the field. Well, in this variety, in this location, you had 300 pounds total taken up. If you add these two together, you'll get 299.9. 72 pounds of it left the field with the grain at a 238 bushel an acre yield difference. Okay, so if 260 removes 65, 238 shouldn't remove 72, but that's what the data is coming from the field. So ignore the textbook, go with what your results are telling you. But it's also telling you that 228.1 pounds is going right back out the back of the combine at harvest. That 228.1 is higher than the soil test at 212.5. See how that's not a drawdown? If that's the case, your next soil test, if this was all a big bank account and you deposited 228.1 back on top of 212.5, then you're talking 440 pounds of K should be in your next soil test. But guys, it won't. It'll be within 10% of this 212.5 would be my guess. So at the total average excess for if I take all of the final yields, all of the final samples, 77.2% of those samples had some level of K excess. And if I convert that into an average of what the amount of excess was for all of those in one big pool, the average was 56.9 pounds per acre. So, well, what does that cost? Well, at 360 a ton, you're looking about $17 an acre of excess uptake. Now, thankfully, versus phosphate, potassium only has like a 20% harvest index. So you're not losing nearly as much. You're putting about $3.50 an acre into the grain that you didn't need to put in there. But there's still cost associated with it, and even 350 an acre if you're making unnecessary applications. That extra loss with the grain that you're sending out because you didn't need that extra K there, um, you can shave that back. Okay, so that's it for K. This one was a little bit longer, had a little more to explain. But if you have any questions, feel free to reach out. And thanks for your time.